Okay, so in the last section we talked about how we multiply two polynomials together. And what we're going to look at in this section are some special types of products. And once you recognize when you have a special product, it can make multiplying it out a little bit easier. So let's look at a couple. So here we have the sum and the difference of the same terms, a plus b, a minus b. Notice that there are two binomials. So if I use FOIL, here's my first terms, and my outside terms, and my inside terms, notice that, and my last terms. And so what I notice is that these terms cancel, and what I'm left with is simply a squared minus b squared. And so that's an important property to notice when you have the sum and difference of the same terms. So let's look at a more complicated example of that. Suppose we have 2x minus 3y times 2x plus 3y. So we have the difference in the sum and the difference of the same terms. So it's simply going to be the first term squared, which is 4x squared, minus the second term squared. So it makes it a lot quicker to do that multiplication if you notice that you have a sum and a difference, and you simply use the rule that it's equal to the first term squared minus the second term squared. One more example. Let's make it a little bit more interesting. So let's get my black back. And let's suppose we have 3x cubed minus 2y to the fifth times 3x cubed plus 2y to the fifth. Okay, so what's it going to be? First term squared. Take a second, what's that going to be? 9x to the sixth minus 4y to the 10th. Okay? So here is our first special product. Let's look at another. So here, let's suppose we have a plus b squared. Now remember, that equals a plus b times a plus b. And if I use FOIL on this, my first terms, then my outside terms, then my inside terms, and finally my last terms. And if I simplify that, do you see what I have? A squared plus 2ab plus b squared. So when you have a binomial squared, it's the first term squared, and then twice the product of the first and the last, and then the last term squared. Many students will be a little bit careless, and they'll say, oh, a plus b squared is a squared plus b squared. And they lose out this term, and they lose some points. So be careful, and one of the ways to prevent that problem is when you have a plus b squared, think of it as a plus b times a plus b, and then you'll never miss these middle terms. All right, some examples. Okay, so let's take a look at 2x plus 5 squared. So it's going to be the first term squared, which is 2x times 2x, or 4x squared, plus twice the product of 2x and 5. Well, if you multiply 2x and 5, you get 10x, and if you double that, you get 20x. And then finally, it's the last term squared. Right? So suppose if instead of a plus we had a minus, in other words, if it was a minus b squared, if you were to write this out, just as we did here, and multiply it out, you should see that you get a squared minus 2ab plus b squared. So almost the same exact thing when you have a minus. And so as an example here, if I had x minus 3 squared, well, that's going to equal the first term squared, then twice the product of the two. Well, x times a minus 3 is minus 3x, doubled is minus 6x, and then plus 9. And if ever you have any confusion with this, just take x minus 3 and multiply it by itself. In other words, x minus 3 times x minus 3, and use FOIL, and you'll get the same result.